Let's start by exploring the difference between the sleep and wait methods in Java. The sleep method is part of the thread class while wait belongs to the object class. When a thread calls sleep, it pauses for a specified time but does not release any locks it holds. In contrast, wait releases the lock, allowing other threads to acquire it. Sleep is a static method and does not throw interrupted exception unless interrupted, while wait is not static and will throw interrupted exception if the thread is interrupted. Sleep is mainly used to delay a thread for a set duration, whereas wait pauses a thread until it is notified by another thread. Both sleep and wait methods come with overloaded versions. For sleep, you can use sleep long millis or sleep long millis int nanos, allowing you to specify the delay in milliseconds and nanoseconds. For wait, there are three options: wait long timeout, and wait long timeout int nanos. This flexibility lets you control how long a thread should pause or wait for a notification, making thread management more precise in concurrent programming. Moving on to strings, let's compare string and StringBuffer. A string in Java is immutable, meaning once created, its value cannot be changed. StringBuffer, on the other hand, is mutable, allowing modifications and various string operations. Strings are not thread-safe, while StringBuffer is thread-safe, ensuring that two threads cannot call its methods simultaneously. This makes StringBuffer suitable for multi-threaded environments where string modifications are frequent. Now let's look at StringBuffer and StringBuilder. Both are used for mutable strings, but StringBuffer is thread-safe, meaning it's synchronized and safe for use by multiple threads. However, this makes it slower. StringBuilder, in contrast, is not thread-safe but is faster due to the lack of synchronization. If you need high performance in a single-threaded context, StringBuilder is the preferred choice. When your application requires frequent updates to string data, using string is inefficient due to its immutability. Instead, you should use StringBuffer or StringBuilder. If thread safety is essential, StringBuffer is the right choice. But if you're working in a single-threaded environment and need better performance, StringBuilder is recommended because it avoids the overhead of synchronization. StringBuffer is called mutable because it allows you to change the contents of the string without creating new objects each time. This is different from string, which is immutable. With StringBuffer, you can append, insert, or modify characters efficiently. This feature is especially useful when you need to perform many modifications to a string, as it saves memory and improves performance. Here's a simple example to demonstrate StringBuffer's mutability. In the code, we create a StringBuffer object and append several strings to it. Finally, we convert it to a regular string and print the result. This approach allows you to build complex strings efficiently without creating multiple intermediate objects, which is what would happen if you used immutable strings. In Java, you can create a string using either a string literal or the new keyword. When you use a literal, the string is stored in the stack memory. If you use new, the string is created in the heap memory, even if an identical string already exists. This distinction affects memory usage and object identity, so it's important to choose the right method based on your needs. An array in Java is a data structure that stores a fixed-size sequence of elements of the same type. Each element can be accessed by its index, starting from 0. Arrays are declared using square brackets, and their size is specified at the time of creation. This makes arrays efficient for storing and accessing large amounts of data of the same type. Arrays in Java are created in heap memory. When you create an array using the new keyword, the Java virtual machine allocates space for it in the heap. This memory is shared among all threads, and the JVM manages it using garbage collection. Once an array is created, its size cannot be changed, and memory is managed dynamically at runtime. Java supports two main types of arrays: primitive arrays and reference arrays. Primitive arrays store basic data types like int or char, while reference arrays store objects. Arrays can also be single-dimensional or multidimensional. Single-dimensional arrays are simple lists, while multidimensional arrays can represent tables or matrices. In Java, array indices start at 0 because the index represents the distance from the start of the array. The first element is at position 0, which is the base address. This convention makes it easy to calculate the memory address of any element using the formula: base address plus index times the size of each element. Both int_array and int_array are valid ways to declare an array of integers in Java. The difference is purely in syntax. The first is C-style, while the second is Java style. Functionally, they are identical, but Java style is preferred for consistency and readability. Java provides several ways to copy arrays. You can use the clone method for a shallow copy system, arraycopy, for a deep copy, arrays copy of, to copy the entire array, and arrays copy of range, to copy a subset. Each method has its own use case, depending on whether you need a full copy, a partial copy, or a deep copy for complex objects. A jagged array in Java is a two-dimensional array where each row can have a different length. This is useful when your data has varying lengths or you want to optimize memory usage. Unlike regular 2D arrays, jagged arrays provide more flexibility and are ideal for scenarios where each row doesn't need to have the same number of elements. In Java, you cannot make an entire array volatile. The volatile keyword can only be applied to individual variables, not arrays or collections. Volatile ensures that the value is always read from and written to main memory, making it visible to all threads. For arrays, you can make the reference volatile but not the array elements themselves. Arrays offer several advantages. They provide direct and efficient access to elements with constant time retrieval. Arrays store data in contiguous memory, making them fast and easy to implement. Their simplicity makes them ideal for beginners and for situations where you need quick access to large amounts of data. Despite their benefits, arrays have some disadvantages. Their size is fixed at creation, so resizing requires creating a new array and copying data. This can lead to wasted memory if the array isn't fully used. Arrays are also less flexible than other data structures like linked lists, and all elements must be of the same type. The object-oriented paradigm is a programming approach where objects are the main entities. Objects have attributes and methods, and concepts like encapsulation and inheritance are central. This paradigm helps organize code in a way that models real-world entities, making programs easier to understand and maintain. Java's object-oriented programming is built on four main concepts: inheritance, polymorphism, abstraction, and encapsulation. Inheritance allows classes to share behavior. Polymorphism enables objects to take many forms, abstraction hides complexity, and encapsulation bundles data with methods. Together, these principles make Java powerful and flexible. Object-oriented programming languages like Java and C# support advanced features such as inheritance, polymorphism, and abstraction. Object-based languages, such as JavaScript and Visual Basic, focus mainly on using objects and encapsulation but lack full support for inheritance and other OOP features. The new operator is used to create objects when you know the type at compile time. If you need to decide the object type at runtime, you use the newInstance method. This allows for more dynamic and flexible object creation, especially in frameworks and libraries. In Java, a class is a blueprint for creating objects. It defines the attributes and behaviors that the objects will have. Classes are not real-world entities themselves, but serve as templates for creating objects that represent real-world things. Static methods are associated with the class itself and can be called without creating an object. Instance methods are tied to a specific object and can access both static and non-static members. Static methods cannot be overridden, while instance methods can be, allowing for more flexible behavior. The "this" keyword in Java refers to the current object. It's used to distinguish between instance variables and parameters with the same name, and to pass the current object as a parameter to methods or constructors. Java uses access specifiers to control the visibility of classes, methods, and variables. The four main types are public, private, protected, and default. These specifiers help restrict access and protect data from unauthorized use. When you define an object reference as an instance variable in Java, its initial value is null. This means it doesn't point to any object until you explicitly assign one. An object in Java is a real-world entity with properties and methods. It's an instance of a class, created using the new keyword. Objects are the building blocks of Java programs, representing everything from data to behaviors. Java offers several ways to create objects, using the new keyword newInstance clone method, deserialization, and the newInstance method of the constructor class. Each method serves different needs, from basic object creation to advanced scenarios like cloning and deserialization. Object cloning in Java allows you to create a copy of an object. The clone method is protected and must be overridden. Cloning reduces code size and supports prototype patterns, but it can be tricky due to shallow copying and the need for the clonable interface. Proper implementation is essential to avoid issues. Passing this to a method has advantages over passing the current class object. This is a final variable and cannot be reassigned, ensuring consistency. It can also be used in synchronized blocks, making it useful for thread-safe operations. A constructor is a special method used to initialize objects in Java. It's called when an object is created and has the same name as the class. Constructors set initial values for object attributes and prepare the object for use. If you don't provide a constructor in a class, Java automatically generates a default constructor. This constructor has no arguments and performs no special operations, simply initializing the object with default values. Java uses two types of constructors, default and parameterized. The default constructor takes no arguments and assigns default values. Parameterized constructors accept parameters, allowing you to set object attributes during creation. The default constructor's main purpose is to create instances of a class with default values. It's called during object initialization when no other constructor is provided, ensuring that objects are always properly set up. A copy constructor creates a new object by copying another object's properties. In Java, you pass an existing object as a parameter to the constructor, resulting in two objects with the same attributes. This is useful for duplicating objects easily. A private constructor prevents other classes from creating instances of a class. It's often used in the singleton pattern, where only one instance of a class should exist. The class provides a static method to access the single instance, ensuring controlled object creation. Constructors and methods serve different purposes. Constructors initialize objects and are called only once during creation. Methods perform specific actions and can be called multiple times. Constructors have no return type, while methods do. An interface in Java is a collection of abstract methods and static final variables. It defines a contract that classes must follow, specifying what methods they must implement. Interfaces enable multiple inheritance and help achieve abstraction. Interfaces in Java provide total abstraction, support multiple inheritance, and allow classes to implement multiple interfaces. They help achieve loose coupling and define a blueprint for class behavior without specifying implementation details. A marker interface is an empty interface with no methods or fields. It's used to signal special behavior to the Java runtime or frameworks. Examples include serializable, clonable, and remote interfaces. Abstract classes can have both abstract and non-abstract methods, support final methods, and allow protected or private members. Interfaces only have abstract methods and public members by default. Abstract classes use the extends keyword, while interfaces use implements. Interfaces support multiple inheritance, but abstract classes do not. Encapsulation is an OOP concept where data and methods are bundled together in a single unit, usually a class. By declaring variables as private and providing public getters and setters, you control access and protect the internal state of objects. Encapsulation provides several benefits. It hides implementation details, increases flexibility by allowing read-only or write-only variables, improves code reusability, and makes testing easier. By controlling access, you protect the internal state of objects from unauthorized changes. Aggregation describes a relationship between classes, where one class contains a reference to another. It's a unidirectional association, meaning one class owns the other. Inheritance, or the is, a relationship, allows a subclass to acquire properties and behaviors from a superclass, promoting code reusability and hierarchy.